recording. So this is building query for August 28, 2020. And the very light agenda that I tweeted out includes a demo from Ramfox on pulling data sets fully P2P, which would be very cool for any of the distributed web folks who are interested in that. And I think we're going to get a small update, kind of like the one you gave this morning, B5, on progress on access control, mostly with a look ahead to what we'll be doing in Sprint R. But otherwise, we can cover any other work that was done in Sprint Q by the query team. And whatever Dan is interested in, we can be sure to cover as well, particularly with the Python stuff that he's been contributing to. Cool. Do you want to have you, Ramfox, demo some of the P2P stuff, pushing data sets between peers?
Hi, yes. Am I visible?
Visible.
Cool. All right,
Visible.
so this sprint we worked on something that's sort of going to be kind of a little bit of a game changer for our peer-to-peer story. We worked on this thing called peer-to-peer ref resolution. So previously, the idea of ref resolution is, hey, you want some data set. Let's say you want data set, I don't know, awesome data set from awesome user. But all you know about this data set is the user's name and the data set name. Unfortunately, query is going to need more information than that in order to find the data set, have all of the info for each commit, and and find all the information for each version of the data set to be able to pull it down. It also, just because we have the user name doesn't mean that we actually know the location that this data set is saved. Because although it might be from awesome user, someone else in the network could also be hosting that. And if they have a node that's online, then you can actually get the data set from them rather than from the original user. So far in our pushing and pulling story, we have been mostly focusing on Query Cloud. So that's super important for us because we guarantee that Query Cloud will be hosting your data and will be up and available. And the way that we do ref resolution there is we're sort of, it's our default. So we expect when you type in query push or query pull that you are asking to push and pull from that Query Cloud. And we can just ask Cloud, in order to resolve the ref and get more information about this data set, we can just point to Cloud and say, hey, give me this information, and Cloud will, unless the data set doesn't exist at all on Cloud, will reliably send us back, hey, here's all the information, here's our logbook, here is each block of data, and we're good. Now, as a query as a project wants to have a few more guarantees than that. We want have a robust peer-to-peer network, and we also want to not have to rely on a centralized service like Query Cloud. We want folks to be able to run their own remotes, we call them. Remotes are special query nodes that are not difficult to set up, that allow you to accept people pushing and pulling to you. So it lets you become your own little sort of hub where you can guarantee, hey, I'm going to be collecting this data, but I'm going to keep it online. Or, hey, you want your data to be reliably online, push it to me. In order to do that, we needed to create a way to resolve references over the peer-to-peer network rather than just HTTP, which we had been relying on for Query Cloud. So in order to do that, the idea becomes then, hey, you're a node that is connected to this network using libp2p. We are built on top of libp2p. And I want to resolve my reference. So I want to pull some data set from some remote that's hosting it. or from peer itself. So I know I want awesome users, awesome data set. So I'm going to make a request to the peers that I know I'm connected to say, hey, do you have information about this peer? About this data set. If they do have information about this data set, they'll send us back a resolved ref. So this is called ref resolution. And in ref resolution, we are expecting two things. For successful resolution, the different parts of this data set reference fully filled out, and also the source where that data set was resolved, because we're going to assume, hey, if you had this information, you're going to be the node that most likely has the data set itself. So we send these messages out, and if there's someone in our network who has that information, they will send a fully resolved reference back. Now I can show this in action. This was actually specifically really important when we are pulling from a remote, because in order to push to someone, you don't need to have that data set resolved because you have that data set. That's your data set. You know all the details about it already. You can push all those details without needing any other extra information. But in order to pull, you need to have someone else resolve it for you so that you can then have the information about where and by what mechanism to pull it. So I'm going to show you the test plan that proves that we can do fully peer-to-peer remote, fully peer-to-peer pulling from a remote. Now I've also just run this to test it. So if you guys just bear with me and I'll walk through what actually is being shown here. Actually, I need to screen share. So let me do that. What are we looking at here? Share. Okay, can you guys see some lovely text out of here? Great, seeing some nods. Cool. So I'm going to minimize all of your faces. So if you need something or want to comment or ask a question, please unmute. And yeah, please, thank you. All right, so in this case, super simple. We have one remote, which is, let's see, which is the red node here. So node 0. And we have one, I'm going to call it puller. And that's going to be in green, node 1. So the first thing that happens is we have to connect these two together. We have to get the remote information. So you need to be aware of this remote before you're able to do the pushing and pulling. And so we add that remote's information as the puller. We add that remote's information into our config. Hey, this is one of the remotes that we're going to rely on that we know exists. Then we connect the two peers. So we know that there's a connection. When you open up query, part of what happens is, and we're built on top of libp2p, and this does some of this for us, there's a discovery service that goes through and actually actively looks for connections. So libp2p does this. It looks for peer connections that speak the libp2p protocol. And then once we get that connection, query piggybacks on top of that to say, hey, this is a libp2p connection. Is this also a query connection? And if so, we add that information into our own personal query peer store, so we know, hey, this person speaks query. I can rely on this connection if I want to get some query information from someone else. So we are the puller is trying to get this beautiful data set. This razzle dazzle rose whatever sheepdog is actually the name of the remote, and megajoules is the name of the data set. So we go to pull. This is all of the addresses that we have for the remote. We're just printing this out for sanity's sake. And then we go and attempt to fetch this from the remote. Now, if you see on the remote side, we get this alert that says, hey, somebody's trying to pull for me. And then on the puller side, we actually, at the end of all of the pulling, this is the thing that says, hey, we've 100% actually fetched this from the remote. And just as a sanity check, we look at the log list. The logs are a list of actions that have happened with this data set, and it's the way that we know and are able to know about each version of the data set that we care about. And so if we list all the logs, we're listing all the foreign logs. So the puller is saying, hey, list every log of every data set that's not mine. And we see that we actually have information about, this razzle-dazzle sheepdogs megajoules data set. So it's confirming that, hey, we have the data set. So we were able to pull, and we did all of this over the peer-to-peer network. If you look at these addresses here, these are all addresses these are all multi-adders that you can resolve using the libp2p network. Okay, so questions? Comments, complaints?
So I do have a question. I'm not sure if this is a bit of a 101 question that maybe most people already know the answer to. This kind of came to my mind earlier, just thinking about how databases are identified purely with this simple ref username and name. What if multiple sources have different versions of the database? Maybe one is more updated. You don't know if you necessarily have the most updated version, or conceivably there could be divergent versions of it. So they have like a common root, but they've diverged into two different places. Conceptually, how is query going to handle this? And maybe that applies to this in particular.
Cool, that's a great question. So logs, so when I was talking about logs before, logs can only be mutated by the person who created the log in the first place. So if you have let's say you pulled a data set and you have, it says, hey, you have 3 versions. You are not able to edit that. And so if somebody else pulls it from you, they also know that that version has not been tampered with. However, like you're saying, if, awesome peer 95 has created a new version of their data set, they append to that log. Now, logs are append only. Logs are like the way that we sort of control all of this craziness. They're append only. So even if you delete the data set, if you change the data set, if you go back and rewind and say, hey, I actually don't think that the commit that I just made is viable anymore, it's always append only, right? So if somebody pulls your log and all of a sudden it's longer, they know, hey, I'm out of date. I need to go pull this if I want to get the correct information. To your point about, so that's the way that we ensure that there aren't any conflicts, basically. But to your point about, hey, how do you know that, node X has the full log, that when it's, a log that is actually node Y's log? You don't actually know that. But if the other node ever comes online and you're trying to resolve that ref again or do something with that data set, you will pull. The first thing we always do in all actions is get the most recent version of the logs. So unless node X comes back onto the network and is participating in the network and has its data available, then you won't know if node X has done anything. If they haven't pushed anything or published it, you're not going to get the most recent version. There are plans in place in our timeline to have a more automatic way of alerting people, hey, your data set is out of date. We already do this on Cloud. If somebody pushes a data set version and you're following that data set, you'll get a email notification saying, hey, they just pushed another version, your stuff is out of date. If you want to take a look at it. On the peer-to-peer side, that's more complicated, and although that is something that we are interested in doing, when somebody does some action to some data set that you have said, hey, I care about this, we want there to be some way for you to automatically know this has been updated, this has been changed, this has been deleted. So currently, to answer your question exactly, that's sort of just like a risk that you take when you're doing stuff P2P, that you don't actually know if this is out of date or not. You know it's not falsified, but you don't know if it's the most recent, unless it's coming from the source that it's talking about. But yeah, does that answer your question?
Certainly. So it sounds basically something like eventual consistency. The only thing I can think of is, so like, okay, the fact that it's append only, nothing like git rebase, and the fact that it's always from one source, cryptographically verified, that eliminates a lot of problems. I could still see a problem with somebody trying to cause problems on purpose by like, you can imagine where like purposely like reverting changes and then pushing to another place and then confusing somebody. So that you don't have to answer that one. I'm sure that's complicated. But that's the only other thing I'd wonder about.
No, totally. And there's other things that are in play that we are in our roadmap in place to be trying to sort of, I don't know, punish bad actors, I guess you could say. But I think right now we're talking a little optimistically. Let's see how many people are excited about this, and are, before we, get the people who are going to be dicks about it. But there's also, we have the next PR that should be coming out maybe later today is a whole thing about access control. So remotes need a way of saying, like you were talking about, hey, this person's a bad actor, let's not let them push or pull anything anymore. Or just as simple as, people shouldn't be able to delete things that aren't theirs, and they can't really because of like all this log stuff, but just other layers of security. So the next layer that we are focusing on is access control for these remotes to ensure that we're able to block people from doing things that we don't like. Any other questions? All right, that's me then. Thanks, guys. I'm gonna stop sharing this random page of nonsense.
Thank you, Kasey.
Very good. Thank you. All right, so moving along in the agenda, B5, do you want to take over and give a little preview of the progress we are making and will make in the next sprint towards access control?
Absolutely. Hi, everybody. Hopefully this survives. My connection here is not great, but back. And yeah, we're talking a little bit, and this is a perfect handoff from what Kasey was saying about access control being the sort of next thing that we want to move toward, and plans about that. Pretty much transition. Yeah, it's very, very smooth, as if we planned it with an agenda. But the hope here is that we've had for the last, we've been working Query for a while. We've had questions about private data and access control for a long time, and it makes a lot of sense, right? If you want to put sensitive data into Query, currently we just tell you don't do it. It's public stuff, and we're not ready for it. But Query's been around long enough that it's now time to really start thinking about the idea of access control and really build on top of, help explain some of the motivation behind a lot of the work that Kasey just demoed. We think that one of the things that makes Query different is its sort of decentralized nature and the idea that it really builds on concepts put forth by version control tools like Git, where you have Git, if you watch the old videos, Git was explained as distributed, and then there's a lot of hand waving around the difference in the word distributed and decentralized. But one of the things that we'd like to sort of, the scenario we're working towards in the near term is the idea of leveraging Query as a decentralized system to push around data that is maybe that shouldn't be sort of just published to the broader public. And so for now, query.cloud is still the place where you go if you want to publish data sets to everybody, which, and we think the query.cloud sort of answers that really well and gives you a whole bunch of features that you won't really get for the foreseeable future on the distributed side, which is like following a data set, really easy download buttons, simple URLs that exist on the regular internet. But the scenario that a lot of folks have come up to us with, and actually we had somebody jump into chat most recently, like 2 days ago, saying, hey, I want to be able to sort of stand up a query node that acts like a sort of central point of coordination for either my company or my lab or a bunch of friends at school or people that I'm working with. And I just want to be able to have this sort of box that I can push data sets to, and it'll hold on to them for me. And we'll be able to sort of use that, not as private data per se, but as a way of skirting around the edges of public, right? So think about this as like unlisted data sets. And from there, there's a whole bunch of things that we can sort of layer on from there. And a lot of this sort of comes out of a project that Chris has kicked off surrounding automation. And we sort of really quickly realized that the story around being able to push and pull to remotes is a really sort of useful concept. And I just realized that I've just introduced a new term. So remote is the phrase for when you want to have a query node that accepts data sets, that is basically acting more like a server, less like a client. So remotes generally are on and like on all the time, ideally. That makes it a lot easier to operate them, but that's not always the case. If you want to, we totally take the scenario where like 2 users jump online and say, cool, I'm going to go online right now, you DM somebody on Twitter, and then you just push and pull to each other is totally acceptable as well. But for all that to work, as Kasey said, we need to be able to like kind of clamp down in a very easy and expressive way the type of people or the types of things people can push to you or pull to you. And it's sort of easier said than done because you need a grammar for explaining what somebody can do. And we've sort of come to realize that the actual major challenge here is at the UX side. It's a lot, one of the big problems is just understanding what do users want to be able to do easily with dataset sort of access control. So common examples are like, I want only these 5 friends to be able to read this data set, and these 2 people should be able to write to it, right? And that sort of sounds like these high level, how do we take those high level statements and work them down into something that a machine can work with in a way that is consistent and easy to understand? And so today we're sort of going to walk through some of the actual lowest level layers of that, which is the actual access control policy documents. And we're going to talk about a feature that is going to launch that actually Kasey has also been spearheading, that allows you to define access control documents, write one of these policy documents, and just place it in a special place inside of your query repository. That if you are running as a remote, it will use that policy document to determine who can push to you and what they can push to you. And we see this as a really great first step, because what we'd like to do then is take this exact same policy document grammar and apply it to the data sets themselves. And so we'll have, in this case, this is sort of an isolated scenario that is a little less complicated than the policy document story for data sets, because policy documents for data sets are going to evolve over time, and they're going to be something that needs to be synchronized. If you think about multiple users who are sharing a access control data set, there are rules about what you can and cannot do with that data set if you want to be a good faith actor with it. So if you have read-only access to that data set and somebody who does not have access to that data set asks you for it in a peer-to-peer context, you absolutely must deny that. And if you don't, you're outside of this, you're acting outside of the policy document. So that's sort of a bit of a long-winded way of explaining this sort of first step. We're going to talk pretty low level today just about the sort of way that we're defining these documents and trying to get our head around some of the possible scenarios that this addresses and allows you to sort of get to. So I'm going to share my screen really quick, and I'm going to stop video so that only one thing is going at a time. But, okay, share desktop 1. Does everybody see a JSON document? I'm going to make it big. Anyone see this? Somebody? Yes? No? Cool. I'm seeing yeses. Awesome.
Sorry, everybody's muted.
So,
yeah, we're good.
Totally. So this is an example of a policy document. We based this, we researched a number of different solutions for this. including the biggies. For us, we're looking at a project called CAS bin, which is a sort of like meta access control enforcement layer that allows numerous different sort of access control models. To name a few different access control models, we have access control lists, which are the common old school way of doing access control, which is a list of rules. And then we have another one, which is out in the sort of public sphere. And then there's the newest one on the block is ABAC, which is, I can just show you some of this stuff. Caspin, we should shout out projects that are good. This is like the biggie project in the Go programming language that is backed by a really nice white paper that allows you to sort of support a number of different models. And so we have access control lists, we have RBAC, which is rule-based access control, and then attribute-based access control. ABAC is a little more complicated, but for us, so we spent a lot of time researching different types. The other thing we looked at a whole bunch was actually AWS's IAM policy documents, which I don't know if anyone else has seen these. This is the way that Amazon Web Services manages permissions. And you will see a lot of similarities between AWS's policy documents and ours. So just really quickly looking through one of their policy documents. Hopefully this documentation leads to one. Yeah, cool. So an AWS policy document looks like this, and you define these, and these allow you to control access to Amazon Web Resources. So we have S3, we have like these are different types of things and different types of stuff you can get. And so with query, we try to arrive at something that sort of comes as close as possible to an existing grammar, but is also as light as possible for enforcing the kinds of things we want to control access to, and has a pretty easy to read data model. It's really important for us that this be something that's very lightweight, because we are going to be embedding these inside of those logbook, these access control policy documents inside of logbook data. So it's important that it be concise and that it be relatively straightforward to parse. And so this is an example of what we arrived at. This is an example access control document that applies to being a remote. So you'll see some commonalities. We've tried to keep the field names as similar as possible, but the actual resources obviously don't need to match anything that Amazon presents. But the document format really closely resembles Amazon S3's IAM policy format. We don't use, but there are some sort of like notable distinctions. We don't sort of use multiple colons to indicate different layers. Instead, we use the star as a globbing pattern, which we'll get into in a second. And then we also include this one other special key phrase, which is underscore subject, which is a way of referring to the person that is making the request. And so with that, we also include, just for sort of human readable reasons, a title field, which I find writing these documents to be quite difficult. And so I actually write the intent of the rule itself as the title. And that, I think, really helped what the actual rule is including. It allows anybody to pull a dataset. And then the second rule, which is has the effect of allowing, pushing, and deleting datasets that you have created. I'm going to check chat. Also, Jason has no comments. Yes, Jason has no comments. Some people in the past in other document specifications have tried to do stuff like this and add like comment text, which I find very difficult and frustrating. So instead we just use titles, because it's titles. And what we'll actually do in the long term is use this as for debugging purposes, and we'll show you the rule that actually allowed or denied something. But this sort of like gets at some of the stuff that we're trying to do. So for now, the thing that will land next, as soon as we land this PR, is you'll be able to define this as a document called, Kasey, what's the name of the file? It's got to be called something special, and it's got to be in a special place. But if you name and save this, oh gosh, I have to go to the PR. Let's look at the PR because it's fun. Remote access control here, work in progress. Isn't this fun? We said the file should be called. Where is it? Oh my gosh, I'm sorry. I should have prepped this beforehand.
It's from access underscore control underscore policy .yaml.
Oh, there it is. Okay. So access control policy .yaml is where what it needs to be, and it needs to be saved in your query folder. So in my case, my query folder is actually home/.query. And so if I were to save a file here called access under control .yaml, then it'll work. We intentionally said YAML because sometimes it's really nice to write these as YAML. YAML is a superset of JSON, so just punching this in will work just as well. Anyways, if you save that file and you put it there, query will enforce these rules when you're operating as a remote, which is a really fun and new thing, which finally allows you a way to deny or allow different people to do different things. And so just to quickly walk through what these two rules are actually talking about. Every rule has a subject, which is the person making the request. So if I wanted to write a rule about user DK, I would be like title DK can do all push and pull. And the subject would actually be not DK. It would be the profile ID of user DK, which I'd have to look up. Sad, not great. But again, we're not designing the UX this go around. We're just designing the low level technology. And so the profile ID will look something like QM foo and be a very long string. And then the resources that I would want to have DK be able to access, would be very liberal here. We should never do this. You should do this in demos, which is just like, hey, I want to be able to access any resource. This policy document describes any resource, and the actions that are allowed are all actions. And again, I can't emphasize enough, you should never do this and have the effect be allow. What this would do, this would actually allow, theoretically allow user DK to change the permissions of policy documents themselves if we had such a capacity. So don't do this. But for these examples, this is a really common these two rules are really common in actual real world rules that we do want to see and want to have exist. It's really normal for users to be able to say, hey, I want you to be able to pull anything from this remote. I effectively want to operate as a public rehosting of data sets. So anybody should be able to sort of push anything that has been pushed to this remote should be able to be pulled. But if we want to, we can restrict what can be pulled. Maybe we have data sets that are massive and we want to say, anything under this sort of like NYC transit data user space, that's just too much bandwidth. I'm in a sort of bandwidth constrained environment. I'm going to say deny that. But then we have down here, we have the like much more, a common pattern of a much more fine-grained rule around who and what can be pushed. So in this case, the subject is anybody. But then we're using a special keyword in resources, which we'll get to in a second. But the things that we're talking about, the actions that we're explicitly allowing in this case, is we're allowing a remote push operation and a remote remove operation. And for those who are playing along at home with the query code base, these actions actually very closely match the library methods. So if we look at query includes a library definition that sort of talks about everything query can do and allows you to import query as a library. So this lib package includes all kinds of stuff. We have config, file, datasets, integration. But if we look at remote, we have this thing called remote methods, which is stuff that remotes can do. And so the first name of the action is remote. And then we have feeds, we have preview, but then we have push and pull and remove. And so the phrases as they come up end up being remote push, which is the type of library methods we want to access, and then the method we want to be able to call or not. They'll deny calling. And then the resources are what describe stateful things that you want to be able to act upon. And so in this case, we're talking about a data set. And a data set for policy document purposes refers to anything about a data set. So that includes its logbook information, that includes its actual version data, that includes any previews or any feeds created about it. And so in this case, what we're and with resources, they map a little closer to, we normally see data set names expressed like this, like B5/World Bank population. This is actually pretty close if we were talking about this in policy control syntax, it would be dataset B5 World Bank population. That would talk about that specific dataset. And so hopefully that explains sort of where this is coming from. We intentionally separate this by colons and not slashes to sort of show that we're talking about policy space here. We're not talking about actual stateful space. And then last but not least, this, we want to be able to say use their own data sets. Basically, users want to be able to push and pull their own stuff. We have this special key phrase called _subject, which allows you to, which basically says whatever the username of the person that is making the request is actually the definition of the resource they're trying to access. So this is a special keyword. There's only two special keywords. We have the star, which is everything. So this would mean you'd be able to push any data set or push and remove any data set. We would definitely not want to write this. But we can do push. In this case, we're saying push any data set that is owned by the request, and then any resource underneath that, which makes for a nice thing. So there are examples of things that are more specific than that, and there are things, but anything more general than this will not match. So if I were trying to push, for example, like feed subject, this would not match this first resource rule. And so what will happen is when you save this document and put it in the magical place, query, and turn on a remote, query will actually go through and check all of these rules for you whenever people try to do the appropriate corresponding action. So when somebody tries to type query push, the corresponding version of this would be like some command like this. It would look like, oh, sorry, pardon me. Let's make my screen bigger. If I try to type like query push -- remote name of remote user, B5/world bank population, because I'm B5 and I'm trying to make world bank population, that would come through and match against this remote push action. And then the data set in this case would be, the thing that we're sort of checking against would be data set B5 world bank population. And so this would match because my username is B5. If I am some other user, then this rule will not apply and will not allow it. And that brings us to the last important detail. If you define this file, everything flips to deny by default. And so basically you have to explicitly allow everything. You can't, otherwise query will just reject everything. So that's a lot. But hopefully this is like just a sort of early primer, ideally to generate some questions about how all of this works and how all of this fits together. But this gets us going into a really exciting direction. What we need to do from here and the remaining steps to actually get us to private data is, actually I'm going to stop my screen share and turn my video back on. But the sort of next steps for this are to actually write some sort of UI on top of this. And so that's where we'll write some sort of types of rules like query access allow, and then a username, and then a thing you want to allow them to do. And ideally those will be very high level common characteristics. But what you should also be able to do is say query access apply as an example. We don't know if that's actually the final context, but like apply, and then just give it a JSON document and say, hey, here's my super sophisticated, super custom set of rules that I don't want to use your silly CLI for like simple stuff. But I want to be able to sort of just get really fine grained and say, hey, I want to be able to talk about just the meta component or just the body component. And so we have those colon separators to get even deeper into data set sort of definitions, which should allow for really expressive policy documents. At the end of this, we will ideally, before we actually write the UI, we're going to go through and do some frameworks, some wireframing around the actual desktop administration of these access control things. I don't know if anyone has ever tried to like properly configure permissions for a Google Doc. Like this is actually hard to get right. And so ideally we can sort of work through some really common scenarios for situations like desktop, where you just want to have basic, obvious controls. But a lot of that is based on user research, where we actually want to talk to people and find out what they actually want to be able to do, and just build those instead of building, every sort of fancy permission bell and whistle. On the other end of the spectrum, do need every permission bell and whistle possible. And that's where this sort of like policy language starts. So we define the really general thing now, make sure that it covers all of the context we want to be able to talk about. And then on top of that, we'll do some research to layer on the actual sort of like easy shorthand versions of this. And then once that's done, we'll actually take everything we just talked about and basically start putting that information in the logbook. And when a user, that will apply all of the stuff that we just talked about to data sets themselves. And that policy information will travel with logbook data, and will mean that, hey, when I do a logbook sync, I not only have the information about what's changed, I have the most up-to-date, can calculate the most up-to-date policy document that describes what I am and am not allowed to do with that data set. So final caveat, this does not cover the actual encryption at rest of the data itself, which is an entire completely different conversation about how to make sure that that data is only, basically to make sure that that policy policy is enforced cryptographically, so that users are only transmitting keys to people who are supposed to have them, and that will enable them to actually decrypt the data itself once we do roll through all of that. But that's the thing that's in the far horizon. But for a number of use cases, that's actually not completely necessary. If you are working with a remote and you're not pushing to Query Cloud, you can now have this wonderful setup where you can stand up a box that anybody in your organization is given access to, and then they can push and pull to and from it. And that will allow you to have effectively private data without any of the encryption sort of bells and whistles. And for many people's use cases, that will suffice. For things like health code compliance, that will absolutely not suffice. But that sort of draws the line.
But for most things that we all do in Google Sheets on a day-to-day basis, like set my team's lineup and other data manipulation, that is more than sufficient with some sensible defaults. Probably. Very cool.
Yeah, does that generate any questions? I know I talk pretty quickly, and we're going to work this all out as a spec, but I wanted to just like see if any questions jumped into your minds as I was sort of talking through it. It's a bit of an early first pass, but want to just sort of like get a lot of these concepts onto the table so that we can talk about them in greater depth when we actually go to write the RFC.
Just confirming something you said. So if someone doesn't have a policy document, but remote doesn't have a policy document, we're assuming they're saying reject everyone. Isn't that true?
Yeah.
Okay.
I think it should be such that if the file does not exist, there is no access control enforcement. So basically we have the current state. And then if the file does exist, then we flip to calling the enforce function, which defaults to denying everything that is not explicitly allowed.
So if there is no policy document,
wide open.
Right, because that's how I did it. And when I heard you say the other thing, I was like, oh no, did I hear that wrong?
Yeah. No, it's the denial applies in the context of enforcing a policy. If there's no policy to enforce, then you have explicitly opted out of access control.
I kind of don't like that because that defaults to wide open. You know, so if somebody doesn't know what they're doing, they set it up and it's wide open, and anything that's done that in the past doesn't do it anymore, you know, any protocol. So that might be some.
That's another, yeah, absolutely, Rusty. And that's where I think that when this actually hits a release, I think we will do two things. It will write a sensible default policy document for you so that you have something as a baseline to edit. And we will, in that same release, we'll roll out our token-based access control for API access. And so now you'll have actual access tokens for the API, which will mean that this whole conversation can't even really be started until you have been given some sort of token by somebody. Yeah, there's a whole other conversation about private networks that we need to get into, but that's, again, just one thing at a time. Cool. That's all I wanted to cover. Does anybody have any? I really want to leave time for questions. If there's no such thing as a silly question in this stuff because it's really hard to get right. And yeah.
No, it's too early for me to be asking questions. You know, it's broad, and I don't see any direction it should point so far. I have to see.
This may be presumptuous and we might want to wait till Monday to talk about this, but what exactly do we want to make the goal for the next build and query call to show off with respect to access control and remotes? Do you think we want to put wires on the UI wires on the agenda? Is that too far ahead?
I think it might be. I would like a chance to sort of kick the tires technically first, just to understand if this actually gets us where we need to go. And maybe just reporting the results on that would be a great starting point. But the other thing the other thing that is quite dependent on is actually going and talking to people and explicitly asking the questions, what are the common things that you would like to do to lock down access to a data set? Based on conversations, because we have had a number of these conversations in the past, the one that we often get is I have a set of colleagues and I want to be able to say these colleagues can write to this data set, or these colleagues can read from this data set. And so we have some tension between the definition of like a group of users and that's, I think, one place where we should really have a conversation and understand what that would look like from a UX perspective. Because then that's like, this gets all social networking very quickly, right? It's very like, oh, now I need like friends or groups or lists or like all of these phrases that sound very Twitter-like. And so we have to try and figure out what that looks like for us in a way that doesn't mean that you have to first establish all your friends and then create the list. Or maybe it does. Yeah, there's lots of questions here.
Yeah, that's why sensible defaults, like anyone, like in Google Sheets, anyone with the link. And even though I haven't friended Rusty and Brendan, I have their email addresses, and that's simple enough. I don't have a special list, even though Google knows it. Are we creeping in on data PRs at that point too? Are we converging on the concept of writing to a data set from somebody else?
Sort of. That's a different neck of the woods where but we're getting, we can define whether or not it's allowed, and then we have to define how to actually do it. And I think that's part of it. But that's another sort of separate conversation, I would say. The current state of the art for that is if you can read a data set, you should be able to fork it. And so if you can fork a data set, then you can, the next thing to talk about is, can I take the existing fork and create a patch that will apply those changes to a local data set? That's the next thing that we'd like to build. And then that patch application would actually have to be done by the user that owns and runs the data set. Cool. There you go. Question. Oh, awesome. Nifty. That's all the business I had for anyone. Does anyone have any questions outside of access control?
I guess that's it. We could say see you in September. I think B5 froze. All right, cool, folks.
Thanks so much.
See you on the flip side.